Okay, organic families. Organic families are groups of molecules that have common structural features, so common groups of atoms. The group of atoms that is common to each of those molecules is referred to as the functional group. So you'll see in the first row here with examples, I have methanol, ethanol, propan-1-ol, propan-2-ol, and so on. All of these molecules here are all members of the alcohol family, and that's because they all have a common feature of at least one OH group, which we call a hydroxyl group. So the functional group of any alcohol molecule is the hydroxyl group. When we go to name these alcohols, you'll notice that the suffix is always OL, and it's really the two letters at the end of the family name, so hopefully that'll help you there. So methanol, ethanol, propan-1-ol, you can see it shows up. You know, even when we have two OH groups, diol, pentane 1,3-diol, you can see the OL at the end. Propane 1,2,3-triol. Oh, there's going to be 3 hydroxyl groups in this molecule. Where are they? Off of carbons 1, 2, and 3. This propane 1,2,3-triol is actually the proper name for glycerol. Maybe you've heard of glycerol. Sometimes you'll see the OH group named as a side group when it's more convenient, or especially when there's a higher priority functional group in the molecule. So when you are naming the hydroxyl group as a side group, it becomes a prefix and we call it hydroxy. So here's an example, hydroxybenzene. Now, hydroxybenzene is very commonly called phenol. Here I have another example. You'll see there's the OL at the end, right? And now that you see this YN, hopefully that's making you think of alkynes and a triple bond. So here we have 5 carbons in the parent, a triple bond after 3, and the OH will be on carbon 2. So how well you understand the lessons prior to this one, right, will really determine, I think, your success with this one. So it's super important to have a strong foundation. Moving on from the alcohols, we have aldehydes. And so you'll see as we go through the aldehydes, there is this C double bond O group, but it is particularly on an end carbon. Aldehydes and ketones are often thought of together because they both contain the same functional group, the C double bond O. The only difference is that the C double bond O is on the first or the last carbon of an aldehyde, which is really technically the first, and we call that a formal group. If it's on an inside carbon, then it's the molecule's a member of the ketones, and it is called a carbonyl group. The aldehyde suffix is al, like the word begins, and the ketone suffix is -one. Now, I've omitted prefixes here. That's because I won't be giving you any questions where you have to name, for example, a carbonyl group as a side group. So you won't need the prefix. Again, we are scratching the surface of organic chemistry, this incredible discipline of chemistry. So you'll see in the aldehyde examples that they end with al, right? Methanal, ethanal, hexanal. Notice there's no numbering. That's because this formal group is always the first carbon, so we never need to number it. You know, you can have a benzene ring with an aldehyde functional group. We'll draw that, benzaldehyde. And here you'll see I've got prop-2-ene-al. So I've put an EN in here, so there's a double bond happening after carbon 2, and the aldehyde functional group, the formal group, off of the first carbon. 2,3-dibromopentanal, right? So there's an aldehyde functional group, a formal group, right, off the first carbon. Ketones, on the other hand, will have the carbonyl group on the inside carbon. And when you have 3 carbons, there is only 1 inside carbon, so we don't need to number it. When you have 4 carbons, there's 2 inside carbons, but whether you number from left to right, it's always going to be the second carbon. So instead of saying butane-2-one, we just say butanone because that's the only way you can possibly draw it. If you put that carbonyl group on a different carbon, it's either going to be butanone again, or it'll become an aldehyde. Once you hit 5 carbons, that's when you need to start numbering the carbonyl group for the ketones. So pentane 2-one, pentane 3-one, 4,4-diethyl. Oops, I am missing a root here, so I'll have to fix that. We'll come back to that one. Okay, carboxylic acid. Here we have the carboxyl group. So C double bond O, single bonded to OH. So I'll just give you a quick little sketch of that here. C double bond O, single bonded to an OH. So the carboxyl group is actually made up in part of a carbonyl group and in part of a hydroxyl group, and therefore we come up with the name carboxyl. The suffix will be oic acid, and this is our highest priority functional group. So whenever we have that carboxyl group present, we're definitely naming this molecule as a carboxylic acid. All right, so some common examples here. Formic acid is, some ants release that when they bite. Methanoic acid. Ethanoic acid you might be more familiar with as acetic acid, and you may recall that that vinegar is typically 5% acetic acid. Propanoic acid, 4-hydroxybutanoic acid. So here we have a carboxylic acid with 4 carbons, right? And a hydroxy, it's saying 4-hydroxy. Remember, hydroxy was the prefix for the hydroxyl group. And so we can start to blend and see different functional groups in the molecules. Phenyl, hopefully that makes you think of a benzene ring. Methanoic acid, so a 1-carbon carboxylic acid with a phenyl group. That's actually commonly called benzoic acid. 2,3-dihydroxybutane dioic acid. So we actually have 2 carboxyl groups, right? And this carbon always has to be the end carbon. So if you've got 2 of them, there'll be one at the beginning and one at the end of the parent chain. If you only have one of these, like we do in methanoic, ethanoic, propanoic, and so on, right, then that's definitely always the first carbon. Then we move on to esters, and esters are similar to those carboxylic acids, except instead of having this H here, that's the acidic hydrogen that makes those carboxylic acids, right? Instead of that, we are going to have another carbon group. So I'll just draw this ester linkage. Looks like that. So there's always going to be a C double bond O, single bonded to an oxygen. The suffix is O8. And these esters are responsible for flavors and fragrances, both naturally and synthetic. Think of the fragrance industry, the cosmetic industry, makeup. Oh my goodness, there's so much chemistry in makeup and fragrances. It's incredible. We can have natural and synthetic sources of scents. So you'll see here that I've put the name of the ester that smells like pear or tastes like pear, orange, raspberry, pineapple. And you'll notice that the names of all of these esters always have a space. So there's always 2 words and there's a space. And then the second word ends in O8. And that's your clue that this molecule is an ester. That's suffix of O8. Amines and amides are the 2 families that contain nitrogen. And the key for the amine family is to see a carbon that will have a single bonded nitrogen. We call that an amino group. Sometimes these hydrogens won't be there. Sometimes there'll be more carbons. But basically, if you recall ammonia, maybe I'll just do this on the side here. Ammonia, right, is NH3. That is inorganic. There's no carbon present. But as soon as you take one of those hydrogens away and replace it with a carbon, now you've made an amine. And if you take 2 of them away and replace it with a carbon, that's still an amine, and so on. So primary, secondary, and tertiary amines. Of course, there'll be hydrogens off of those carbons to make sure they're stable, but the idea is that these amines are derivatives of ammonia. They can be a little tricky to name, and I've put in some examples, but of course we'll go through them together. And then there's the amide. The amide is like the esters. So it has the C double bond O, but now it's single bonded to a nitrogen instead of an oxygen. And there you go, the amide linkage. If you've taken biology or have some experience with linking amino acids together, forming peptide bonds. Those peptide bonds are amide linkages. Sometimes you're going to see these capital N's out in front of these amine names or amide names. So that's actually telling us we're going to name a parent, and then whenever we put the capital N there, we're indicating what groups are directly bonded to the nitrogen. So I'll go through that when we hit some examples. All right, in terms of naming, you are going to see multiple functional groups in some of these questions. And so the first step is to always give the highest priority functional group the lowest possible number. So don't forget everything you've learned. We're finding the parent chain, right? And the parent chain will include the highest priority functional group and any double or triple bonds if they're present. We're going to drop the E of the parent name, right, whatever it is, and add the suffix. If necessary, we'll use di or tri, and I'll just draw your attention to this up here in the alcohol examples, pentane, 1,3-diol. Notice we didn't drop the E here, right? We did not drop the E, and that's what I'm saying here. Use di and tri if necessary. So if we do have multiple functional, let's say OH, so hydroxyl groups in a molecule, then we don't drop the E, right, from the parent chain. Otherwise, we do drop the E. So you're very commonly going to be dropping the E. Notice this, propan 2-ol, we drop the E. Butan 1-ol, instead of butane, we drop the E. So very commonly you do that. And we're not going to number the suffix if there's no other possibility for it. So remember I mentioned propanone, that acetone. You can't have that carbonyl group on the first carbon of those three or the last one, because if you did, it would be an aldehyde. So there really is only one place to put the carbonyl group in propanone, and therefore we don't number it. It's always propan 2-one, so we don't number it. All right, and the last box here on the bottom right gives you the list of priority. So I've organized this in three categories, A, B, and C. So anything in A is higher priority than B, right? And B is higher than C, which means that your alkyl, halo, nitro, and phenyl groups, which you were introduced to early, those are the lowest priority. So when they're present, right, we just name the structure as alkanes with these side groups, and you've been doing that all along. When double or triple bonds are present, then we have alkenes and alkynes, and they take higher priority, and so we will always number to give the double or triple bond the lowest possible number when we have any of these substituents indicated here in C, right, in the presence of a double or triple bond. And again, you've already been doing questions with those. So really what's new is these ideas here. And you'll notice there's an order of carboxyl at the top, then formal, hydroxyl, and amino. And actually, I should be inserting into here, so I will add this in, the carbonyl group. So carboxyl, formal, carbonyl, hydroxyl, amino. So if we have multiple functional groups present, whichever functional group is highest in this list, right, that's what we'll use for the suffix. Everything else becomes a substituent. Okay, so that's everything you need to know about naming and drawing these families. So the rest of the video then is going to be examples. Okay, so we'll look at example A here. Recognizing the halogen group and the hydroxyl group, we check the priority list and the hydroxyl group is higher. So we'll number the carbons in the longest continuous carbon chain to give the OH the lowest possible number. Okay, so I've boxed out the OH because it will be the suffix, and I've numbered so that it has the number 2 as opposed to from the other direction it would have been a higher number. Now we can see the 3-methyl and the 4-chloro. So we'll need to sequence our substituents alphabetically, so the chloro before the methyl, and then we'll have our pentane, drop the E, and number the OH group, and finish with the suffix. So here you can see the 4-chloro, 3-methyl, pentan, 2-ol. All right, part B. Again, look to number the parent chain, recognize the functional group. Hopefully you're thinking that's a formal group, so we go ahead and number the carbons and see that there are 3. I think that formal group makes this molecule a member of the aldehyde family. So we will write out our parent alkane, propane, but drop the E, and finish with the Al of propanal. Checking example C. We recognize the functional groups of a double bond and the hydroxyl group. Go back to your priority list. You'll find the hydroxyl group is in group A and the double bond is in group B, so definitely the hydroxyl group takes priority. So number from the right in order to give that hydroxyl group the lowest possible number. And now we can build our name here. So instead of butane, it's actually butene, isn't it? But-3-ene, but we're going to drop that E and indicate where that hydroxyl group is. So but-3-ene 2-ol. All right, here we have a 2-carbon molecule that has 2 hydroxyl groups. And so our parent is ethane. We do not drop the E in this case, and we number the location of those hydroxyl groups. Okay, a few more examples here. Now we check example E, and we see that carbonyl group on an inside carbon, so this is a ketone, right? And then we also see that benzene ring there. So check your priority. You'll find that the carbonyl group is higher in priority than the benzene ring, and so the benzene ring will be named as a phenyl, and we want to give that C double bond O the lowest possible number. So it's closer to the left end of the chain. So I will number 1, 2, 3. Yeah, it would have been 5 from the right, so it's 4 from the left. So I can see the phenyl off of 7, right? So we'll have 7 phenyl, and then we go into our oct N, right? Drop the E, 4 one, and there's our suffix for the ketone family. Okay, I gave you an example earlier about benzoic acid, and that's really what we're seeing here. If you named it as a carboxylic acid, right, recognizing the 1 carbon here, then we would have called that methanoic acid. But of course it has the phenyl group off of that 1 carbon, so we would have needed to name it phenyl methanoic acid. But this is commonly known as benzoic acid. If you were going to pull it off the shelf in a chemical supply store, it would say benzoic acid. So recognize the benzene ring carbons cannot have the carboxyl group on them. They'd go far beyond the octet, so this is sufficient right here. You need to have that carbon off of the ring. Okay, moving on to G. Check out this functional group. We've got C double bond O. I'll use the highlighter here. We've got C double bonded to an oxygen, right? Single bonded to another oxygen. There is your ester linkage. So esters, how do we name the esters? Well, first, start at that C double bond O carbon, and that's always carbon number 1. Now number away from the single bonded oxygen. So 1, 2. All right, when you find that, there's your parent, okay? So that's the second name. So ethane, we drop the E and go with the suffix of 08. So ethanoate. Now make sure you put a space. So I'm just putting a little V here to remind you of that. Make sure you put a space. And now on the other side of the single bonded oxygen, count the carbons. So 1, 2, 3. Monkeys eat peeled. There is propyl space ethanoate, propyl ethanoate. All right, let's try H. Find the C double bond, the carbon of the ester linkage, right? The carbon of the ester linkage. There it is right there, 1. Now number away from the single bonded oxygen. 2, 3, 4. There's your parent. So but-ane, drop the E and add the suffix. So again, same pattern with all of these. Find the parent, drop the E, add the suffix. Now, for the ester, we have to look on the other side of the single bonded oxygen, so I'm emphasizing the space there, and I start numbering these carbons, always moving away from the single bonded oxygen. So you'll see I have 2 carbons and a chloro group off of carbon 2. So the first word of this ester is 2, oh, I think I'm going to run out of space, just a moment. There we go, 2-chloroethyl butanoate. So remember the word in front of the space. So the first word in the name of the ester comes from the group of atoms on the away from the ester linkage. So on the other side of the single bonded oxygen. So I'm looking over here, right, for this word here. And the ester linkage carbon, right, I go away from the single bonded oxygen to get the second word. All right, I've got I and J here. So what family are we looking at? What functional group do we see? Hopefully you're seeing that ester linkage, right? So again, we have that ester linkage, which I'll highlight. Okay, so you have a couple options here, right? We go to that ester linkage carbon and say that that's carbon number 1. So, but perhaps with the benzene ring, you'll recognize that this is actually like that benzoic acid. If I had covered this part up and just had an H right beside this oxygen, right, then that would have been benzoic acid. So it's actually, we're actually going to call that second word, instead of benzoic acid, we're going to call it benzoate. And if you check a bunch of food products, you'll probably see sodium benzoate. It's a common preservative. Anyways, this is not sodium benzoate because we don't have the sodium ion here. Instead, on the other side of the single bonded oxygen, we have 2 carbons. Monkeys eat. E stands for eth, and we name it ethyl space, so ethyl benzoate. All right, let's do J. I purposely did this one because it looks similar. We still have the ester linkage, and we still have the benzene ring. But the difference is, look where that C double bond O is, right? There's carbon number 1, right? And if I go away from the single bonded oxygen, I actually go away from the benzene ring. I actually go the other way. So there's my ethanoate. From ethane, I drop the E and get the O8. And now in front of that, right, in front of that, I have the benzene ring on the other side of the single bonded oxygen. And so we have phenyl ethanoate. All right, last 4 or 6 or 7 examples here just had nitrogen in them. So I wanted to go through a few of these for you. All right, so amines or amides. If you don't see oxygen and the nitrogen in the same molecule, then it's an amine. Okay, so oxygen and nitrogen, like you see here, oxygen and nitrogen, these are amides. All right, there's no oxygen here, just nitrogen, so these are amines. All right, so same thing as before. Find the parent, drop the E, add the suffix. The suffix is amine. So let's do K. So I've numbered the carbon, happens to just be one of them. Instead of writing methane, I drop the E and add amine, so methanamine. I do look at the nitrogen to see what's bonded to the nitrogen, and I notice there's just hydrogens there, so that's all I need to do. This is a primary amine. Then I look at L, and I see, okay, longest continuous carbon chain, 1, 2, 3, that puts the amine or amino functional group off of carbon 2. So I have monkeys eat peeled. P stands for prop. Instead of propane, I drop the E, and now I can indicate where that functional group is. So for the amines, right, once I hit 3 carbons in the parent chain, I need to start numbering. Because if there's only 2, then it has to be on the first. And if there's only 1, it has to be on that 1. I check to see what else is bonded to the nitrogens besides the parent chain, and I see it's just hydrogens, so that's it. I'm finished. Now let's look at M. Oh, M's a little interesting. We have 2 hydrocarbon groups coming off of the nitrogen. And so there's an H here, which you don't see in the line structure, but I'll fill it in just to help you out there. So this is now a secondary amine because 2 of the hydrogens in ammonia have been replaced with carbon atoms. So we need to choose the longer of the 2 R groups here. So the fact that there's 2 carbons on the right here, I'm going to go with ethane, or drop the E, ethanamine. So ethanamine. Now, what's bonded to the nitrogen? Well, there's a hydrogen here, right? But then there's also a methyl group. And so we need to indicate that that methyl group is bonded to the nitrogen, and that's where the capital N comes in. So N-methyl, and it's all one word, ethanamine. Okay, so just to be super clear, we looked at the nitrogen, saw 2 carbons going one way, 1 carbon going another. So we picked the 2 as the parent, ethane, drop the E, add the amine, and then we indicate what's also bonded directly to the nitrogen. Here we had 1 carbon, methanamine. Only hydrogens are bonded to the nitrogen, so I don't need to put anything in front. Here, propane, right, drop the E, number where the amine functional group is here, the amino, so propan-2-amine. What else is bonded to the nitrogen? Just hydrogens, so nothing in front. Here, 2 carbons, ethanamine. What else is bonded to the nitrogen besides hydrogen? Oh, this methyl group, so N-methyl ethanamine. Now check this one out. This is a tertiary amine. There's no hydrogens on this nitrogen. There are 3 R groups. We have 3 hydrocarbon groups. We've got 2 ethyls there and a methyl. Okay, so one of those ethyls is going to count as the parent. So we'll have ethane, drop the E, amine. And then we come over and say what's in front, right? What's bonded to the nitrogen. So we have N-ethyl and N-methyl. And it's all one word, so I'm trying to write that so it moves right together. Okay, notice that I arranged those alphabetically, E before M. All right, and that leaves us with O, P, and Q, which are amides. Okay, so how do we name the amides? Well, much like the esters, you find that amide linkage carbon. So here it is here. And you number away from the single bonded nitrogen. So here we have 2 carbons in the parent. So ethane, drop the E, amide is the suffix. So again, we're doing the same thing every time. Parent, drop the E, put the suffix on. So ethanamide. Is there anything bonded directly to the nitrogen besides hydrogens? Nope, just these 2 H's, so there's nothing to put out front. Let's try P. 1 carbon here, number away from the single bonded nitrogen. So again, we have 2, so there's F and amide. What else is bonded to the nitrogen besides hydrogens? Well, actually there's a methyl group. Here it is here. There's a methyl group there. So we indicate N-methyl ethanamide. All right, let's try Q. See the amide linkage? There it is there. So mark the amide linkage carbon as the first carbon and number away from the nitrogen. So there we go. Propane, drop the E, add the suffix, propanamide. Now, what's happening on the other side of the nitrogen? Well, we have an ethyl group here, and we have a methyl group. So N-ethyl, N-methyl, propanamide. Okay, some of the examples that were in the table I've actually done here, and others I haven't. So I will make sure I post drawings of all of those examples that were in the table that you used as the handout of the lesson. I would suggest you try to draw them yourself, right? And then correct by looking at that answer list that I post.